Alrighty, everyone, this is meteorologist Timmy Albertson here with you guys for tonight's weather chat. Hey, before we begin, have you ever wanted to have your own meteorologist making personalized forecasts for you? Well, then you are in luck. AWSC finally got everything worked out for you to have the possibility for having your own meteorologist forecasting for you. Well, actually, it's not a possibility. If you want one, you can have one. We got a bunch of meteorologists across the country. All of us are degreed meteorologists, and we all have experience doing forecasting and everything like that. If you would like to know more, head over to the website americasweathersc.com. And for those of you who decide you might want to sign up, you can use the promo code STARTER23, and that'll get you a little bit of a money discount there. So, fun stuff. And some of you guys, again, with winter coming up, you might want to look into getting that. All right, so there it is, americasweathersc.com. Use the promo code, head over there, sign up. And hey, if you live in Minnesota or Wisconsin, you get me also doing some of the forecasting. All right, with that in mind, folks, we got ourselves some interesting weather right now out across the country. As a matter of fact, for those of you who are winter lovers, and I am one of those people, I absolutely love the winter. Why else do you think I live up north here where it is? Let's take a look here over at some cameras because we got some snow falling out across parts of, you guessed it, Colorado. Let's go ahead here and we'll flip over the screen. Take a look there from the Colorado Department of Transportation. There is a nice little site there. This is at the Loveland Pass looking toward the west. Obviously, since you're kind of in a mountain, if you look straight west, you see mountain, but you can see there is snow there on the roadways. Pretty interesting, huh? That's all that area of low pressure that we've been talking about the past couple of days that is going to, continue to track its way through the central part of the U.S. So let's go ahead and take a little bit of a look here at the radar imagery. Now, again, this is just precipitation. We're not including, we're not differentiating between rain and snow, at least on this particular radar image here. But what we're looking at was down here west of the Denver area, pretty much right around here. I had it set up here to the location. It was right around here, around the Silverthorne area, again, was where we're looking at there. Now, mind you, there is precipitation falling, and when you have a lot of mountains around too, that also kind of helps things out a little bit, given the higher elevations, and also something known as orthographic lift, which does sometimes play a very interesting role when it comes to mountain meteorology. Anyways, before we go any more into that, diverge into that topic, hey, let's go ahead and zoom out a little bit and let's talk about this area of low pressure here. Now, again, we got this little guy that's tracking its way right now through Wyoming and back down into Utah, a little cold front pushing its way through there. But that's not actually going to end up being the main area of low pressure that we're going to be talking about tonight. It's actually this guy right here. So we'll go ahead and we'll flip on over to the surface chart here, and let's go ahead and take a look at what is going on. So if we take a look here at our surface map, we got a pretty well-developed area of low pressure. Now, if you'll notice back out across the mountains, temperatures there in the 20s and 30s. Again, they are seeing snowfall there. We got heavy snow reported at one of the observation sites here. And what you'd expect for higher elevations this time of the year, to be seeing some snow. But here's where it gets pretty interesting. So we got a lot of colder air up across the mountains, all right? And that colder air is working its way down the mountains. Now, as air descends, it begins to compress and it actually warms as it does so. And you'll notice here that we have this little symbol on this map here. Maybe you've never seen this before. This is called a dry line, all right? So what is the dry line here and why is it located on this map? So we have that warmer air that's descending, or we have that cold air that's descending down the mountains, and it's warming as it does so. Now, it lost a lot of its moisture, obviously it's snowing out there, and also just in the fact that it's descending, loses a little bit of its moisture. That causes a hot, dry air mass to be at the base of the mountains. So, cold and snowy up at the mountains, well, chilly and snowy up at the mountains, that air descends and it warms as it does so, and it loses some of its moisture there. Check out some of these dew points here. 27-degree dew point, but the temperature is 83 degrees. So you'll notice very warm temperatures, relatively speaking, out across far western Kansas, going back into the Oklahoma Panhandle and parts of the Texas Panhandle. Look at that. Some of these temperatures here, 92 degrees up in the Texas Panhandle. Dew point, though, 37. So that's a very dry air mass. Now let's look over into Oklahoma here, and you'll notice their temperatures are pretty warm, but not quite as hot. They're generally sitting in the mid 80s across Oklahoma going back into Kansas. But look at the dew points, noticeably higher, sitting right around 60 degrees. So that's what that little symbol here is. This is the dry line. And so basically we have a hot, dry air mass behind it and a not as hot but more humid air mass ahead of it. And long story short, especially when it comes to spring, dry lines are very helpful when it comes to producing severe weather. In this type of setup right now, it doesn't look like there's going to be much of that, but that is a dry line nonetheless. And you can see it just kind of snakes its way down through the higher elevations there in West Texas. And because the plains are actually, the elevation actually increases the further to the west you go across the Great Plains, that air will continue to descend a little bit and warm as it does so. And a lot of times we'll sometimes see that dry line kind of extending its way further off towards the east. All right, so with that in mind, there's a fun little fact for you. But overall, this is all attached to an area of low pressure, which right now is trying to get itself better organized in eastern Colorado. Now, if we were to take a look at the upper level charts, we basically now have kind of this broad upper level low. Whoa, get that out of the way. This kind of broad upper level low that's beginning to push its way across Idaho and into Wyoming. This will become more of a closed low as we go through the overnight tonight and heading into the day tomorrow. Now, what you're looking at here is the height map. I explained that a couple of nights ago, but for those of you who don't know, what we're looking at here, a lot of times when you see these lines, you think about maybe pressure or temperature, but in meteorology, we like to confuse it every now and then. And when we talk about upper levels, a lot of times what we're actually mapping out here are the heights. Heights of what? Exactly. Good question for those of you wondering. So we're looking about 20,000 feet or so up in the atmosphere here. And what we're actually looking at is what is known as the 500 millibar. I'm going to double check this to make sure that we are on that. Yes. All right. This is known as the 500 millibar level. So let's think of pressure here for a moment. You got the air, okay? Surface all the way up to the atmosphere. Because of gravity, the air is densest down at the surface. The average pressure at the surface, the average sea level pressure is about 1012, 1013 millibars or so. Okay, that's the unit we use in meteorology for measuring pressure. Some of you might have heard of inches of mercury. That can also be used, but we like to stick with millibars, and there's a lot of other uses for that too. So with that in mind, though, millibars. So about 1012, 1013 is the average at the surface, okay? So as we go higher up, though, that pressure begins to drop, okay? Again, most of the air is down at the surface and not as much up top, so pressure is lower the higher up you go. If an air column is cold, okay, it's not as tall, okay? It's a little bit lower. So what we're looking for here on these maps is the height at which we hit 500 millibars. So it's going to vary depending upon where you are based on the overall atmospheric temperatures. In this case, right here over the Ontario-Quebec border, we've been talking about the past couple of days, 500 is 5,400 meters. All right, you go up to that height, that's when you hit the 500 millibar level. However, down and across Oklahoma, it's 5,700 meters. Okay, so only about 300 meter difference, but in atmospheric, that is enough to have a little bit of a difference. And again, a lot of times with the pressure gradient force, we got those winds that are kind of trying to move towards the lower area of pressure, but then of course the Coriolis force kind of tilts it a little bit in another direction, as well as some other things going on. And friction is normally not as big of a deal up at this altitude as it is down at the surface. So a lot of times when we show these pressure or these height maps, you can almost kind of think of these height lines as where the wind is per se. All right, what do I mean by that? Let's go ahead and take a little bit of a look over at this guy down here. Now, again, we're looking kind of, this would be to a degree what we would kind of call a jet streak. All right, you've heard of the jet stream. A jet streak is an area within the jet stream that has a high maximum wind, okay? And there's a lot of things that happens when we talk about these jet streaks. But the main thing to know here is that why this is important is because the upper levels will help the lower levels to intensify. And again, they both work together. Okay, it's all connected. Okay, but for simplicity, let me explain this for you. So where we see these height lines kind of close together, that's where we tend to see winds a bit stronger. Again, pressure gradient force a lot higher. All right, so and again, because of factors, it gets pushed over towards the right. So the winds travel from up here, right behind me there, and they're moving that way, okay? West to east. We all know that, at least in the northern hemisphere. Okay, so when we have these little jet streaks, here's what's happening. The air is speeding up now as it tries to round the base here where these height contours are tightest. So there's a lot of convergence going on here in the upper levels. There's a lot of air kind of running into itself because it's all trying to get funneled down into this kind of small area, relatively speaking. So the winds are speeding up basically in this part here of the upper level trough, or in this case, we're using kind of an upper level low as an example, but they're the same thing. Well, anyways, all right, so the winds are converging at this location in the upper levels. But here the winds are slowing down and they're spreading out. That's called upper level divergence. Wow, a lot of terms for you here. For those of you who are still with me, trust me, this is going to make sense here in just a quick second. So upper level divergence we got going on over here. So the air is moving away, all right? So there's not as much air there. So at the surface, we have an area of low pressure. That's low level convergence going on here, all right? Excuse me, wow. We try that again. That is low level convergence going on down at the surface, all right? It's all trying to get together. That low pressure lifts that air up. It's warm, it's moist, it's not as dense, easy to lift. Low pressure, good at that. Brings it all the way up. That air's got to go somewhere. So when there's upper level divergence, well, guess what? There's room. That's where that air goes. Now, on the back side of it, we have a lot of convergence. So at the surface, you'd expect an area of high pressure. At the surface, high pressure is air divergence. It leaves, it gets pushed outwards. So you need something to fill that. So that's where the upper level convergence comes in. See, it's all making sense now. All right, so basically, long story short, we see quite a bit of upper level divergence happening over in this area. And that is good news for our good little friend down here, this area of low pressure. It now wants to intensify more. And it's got the air mass for it at the surface. Look at that again. That is a very warm, moist air mass there. That low pressure likes that. That's good. That is easier to lift than the air that's over the mountains, believe me. So, long story short, that's kind of what's going on. Take a look, though, at the temperature contrast. Now, mind you, folks, this is a couple hours old here. We'll take a look at the radar imagery here, and we'll maybe pull up some current surface observations in a bit if we have time. But here's that warm frontal boundary. Okay, look at that, 85 degrees northern Kansas and even parts of southern Nebraska. And just to the north of that, see how those temperatures drop off. So we got a warm air mass that wants to keep moving. Problem is at the surface here, at least we're talking now, we're strictly talking at the surface here, or at least the lower levels. Problem is that a cool air mass is a lot harder to move. It's denser. Warmer air is less dense, especially warm, humid air. So here's the problem. That air's got to go, that air, believe me, we saw with the upper levels here, if we go back here a little bit, we can see those winds are trying to move a little bit. In fact, if we were to actually go down just one more level here to about the mid-level, as we call this in meteorology, so now we're looking about 8,000 feet up above the ground. You see how those winds are kind of coming in from the south. So this air is wanting to move, okay? It wants to move northwards. Problem is, though, is we got a cooler air mass that is in place. So that air at the surface that's warm, it can't move that colder air, so it's going to go over it. And we call that overrunning in meteorology. And again, in the wintertime, this is a lot more pronounced when we talk about big winter storms, because a lot of times that's when we would see the heavy snow is going to be north of all of this, where all the overrunning is happening. That warm, moist air's got nowhere to go. But up over the colder air, it actually produces a very stable environment, a very stable atmosphere, believe it or not. But it creates that stratus, those low clouds, and all that precipitation. So that's going to be kind of the general setup here as we go through the next couple of days. That's probably going to be a little bit on the rainy side up across the upper plains. But what about the central part of the plains here? So we got this warm front that's trying to lift its way up towards the north. And again, it will kind of erode away some of that colder air. So we'll probably see that front maybe jump just a little bit more to the north, but ultimately it will likely stall out. WPC kind of illustrates this pretty well here on their map. So this is going into tomorrow morning. That low pressure begins to move out of Colorado as that upper level low kind of begins to move more so in. And take a look, there's our dry line still hanging out ahead of the cold front. But notice how our warm front kind of stalls out. Again, it cannot advance. That warmer air at the surface is really struggling to advance because we have a colder air mass that is up towards its north. Not only that, but if we want to talk about pressures, we have an area of high pressure up across northern Manitoba and a very low area of low pressure. Yeah, very low area of an area of lower pressure. Boy, it's been a long day, folks. An area of lower pressure right across parts of western Nebraska and Kansas. Low pressures cannot move a high pressure. High pressures are always the dominant thing. So, for that low, it kind of wants to turn, but it can't because that high is in the way. So again, we got a lot of overrunning here happening. You can see how these pressure now, again, with this map, this is looking at pressure. These are pressure contours, not heights. All right, now we're just talking about surface pressure here. And kind of like what we see with heights in the upper levels where these pressure lines get closer together, that's a tight pressure gradient. Winds are probably going to be at least a little bit gusty there. Again, it's that warmer air, that moisture air getting lifted over the cooler air that's in place. And take a look at that. You can see that rain kind of stretching out almost parallel to I-80. For those of you who know your interstates, that's actually ironically, yeah, that's pretty much ironically right over I-80. That's ironic. Fun times. All right, so a lot of rain there. This is looking at tomorrow morning. But again, we still have a lot of warm and moist air here, and we got a dry line coming through and a cold front. And not only that, folks, but if we were to go ahead and kind of, take a look at what this upper level trough might be doing here, or not upper level trough, this upper level low by the time we get towards tomorrow, take a look there, closed, all right? And again, this is a height line too, but we're not showing winds this time. This is vorticity. We'll talk about that some other time. But long story short, there's our center of our upper level low, area of divergence happening right here, and probably a good amount of, upper level winds kind of, changing their direction with height in this area. So there is going to be a little bit of wind shear. Believe it or not, severe thunderstorms are going to be possible out across parts of Nebraska and Kansas as we go into the day tomorrow, especially as we head into the afternoon. So let's take a look at this. The cold front does kind of meet up eventually with the dry line. And again, in this situation, the dry line, not really going to be much of a big player. Obviously, the cold front's going to be catching up with it. But what I really want you to take a look here is we got this area of low pressure, that warmer air trying to advance this colder air coming through here. And we're going to have a little bit of some wind shear. Could very well be seeing maybe some strong thunderstorms across parts of eastern Kansas and eastern Nebraska as we go into tomorrow afternoon. Be interesting to see, exactly how much shearing is going to be around. Could very well see the possibility of maybe some of those storms trying to rotate a little bit there down across that area. But again, this is not going to be a widespread severe weather outbreak, at least the way things look. There have been times where they give you a little surprise. But right now, it's not looking like that's going to happen. Kind of the main thing with this is really just going to be that rain across northern Nebraska going back into the Dakotas and right into parts of Minnesota too. So this is looking into tomorrow evening. By the time we get towards tomorrow evening, you can see the cold front begins to run out ahead of that, of the warm front, and that creates that occluded front there. So now we got colder air that's advancing into colder air. Again, it's beginning to cut off the inflow for the low pressure at the surface. Now, a lot of factors go into this, and typically when you start seeing this, the low pressure will do, here's a big weather term for you, retrograde, move backwards a little bit. We'll talk about that some other time. But basically, here's what's interesting. When we start seeing that happen, typically that low pressure, at least at the surface, reaches its maximum intensity. But a lot of times we'll see a new area of low pressure developing right around the triple point, as we call it, where the warm front and the cold front, meet up together. There's that occluded front. And take a look here. It's looking like as we go into Friday morning, there's our low kind of, still occluding a little bit, but still moving. And then boom, new area of low pressure looks like it's going to take over somewhere over northern Illinois, and that'll help continue this system as it goes over towards the east. So we're certainly expecting some rain. I think that's kind of a given across much of the upper plains going back into the upper Midwest. As we head into the weekend, rain is going to be likely, especially across the Great Lakes area and maybe going into the Northeast and Mid-Atlantic. So probably going to have some wet football games. I'm a Penn State grad myself, so I always like to watch the Penn State games, and I believe they're home this week at State College. It's probably going to be a little bit on the rainy side, especially if it's an evening game. So there you go with that. So a lot of cool things going on here, especially with that area of low pressure. And again, this time of the year and actually all throughout winter, these low pressures tend to be pretty strong. We tend to see our strongest low pressures typically during the wintertime, at least in the northern hemisphere. And they create some very interesting weather. So again, we're talking about snow right now up in the mountains and the possibility for some severe thunderstorms across Nebraska as we go into the day tomorrow. Especially late afternoon going into the early evening. One thing I do want to double check here is let's take a look here at the surface observations down around here. And let's see here, north of that warm front temperatures, surface temperatures in the 60s, dew points running in the 50s. Below that, dew points a little bit higher, but temperatures certainly still more mild, and it's about 8:30 Central Time in this area. So overall, well, you get the idea. So still pretty pronounced there. Not as pronounced as it was a little bit earlier, but certainly a very warm air mass, especially for this time of the year. Let's see how things are down in Oklahoma City. I mean, they're all going to be relatively similar. Yeah, right now, lower 70s, upper 60s, dew points hanging out in the lower 60s for the most part. So again, certainly a kind of a warm air mass out there. All righty, everyone. That was pretty cool. I think it's really cool. I hope you do too. But yeah, so that's what we're going to be talking about as we go through the next couple of days. We're going to watch as this area of low pressure begins to track its way forward. Let's see what the WPC has as we go into the day Saturday. Yep, there it is, still kind of making its way through. An area of high pressure up towards the north across the Canadian prairies. So yeah, pretty cool. Pretty fun. By the way, we do actually have a tropical system. I did not get a chance to make a graphic for it, but let's go ahead here and we'll just take a look at our good friends over at the National Hurricane Center. And you've heard me say this before. A lot of times when it comes to hurricane forecasting, we all just like to use a unified forecast in meteorology, so it's generally kind of the same forecast, and it's normally the National Hurricane Center's forecast. This is Sean. Sean is struggling a bit. Weak tropical storm right now, but it looks like it could be maybe running into a little bit of wind shear later on. There's also another area, albeit we're still looking pretty far out coming off the Cape Verde Islands off West Africa. We'll see what that does as we go into the weekend to see if that does anything. As far as above and below average temperatures are concerned, let's talk about that. Looks like below average temperature is going to continue as we go into next week, mainly across the deep south, and then some above average temperatures up across the west coast. That would kind of line up with what we're seeing here. Again, if we were to kind of take a look here at our upper level charts and everything, we see as we go in towards the end of the week, upper little trough there, so we're probably going to see it sticking around a little bit, some ridging up there if another system comes through. So anyways, that's just mental forecasting there. All right, so I think we've covered just about everything that we needed to cover in tonight's weather chat. Let's take one more look over at Colorado. There you go, there's some snow for you. This isn't the only place seeing snow right now, but that looks like kind of a wet snow too. That does not look like a light powdery snow. Obviously, the temperature is sitting in the 30s. It tends to be kind of a wet snow there. Certainly, nonetheless, it looks to be like a snowplow, I believe, in that image. Anyways, there we go, folks. Fun times. Alrighty, everyone. Just in case you didn't get a chance, to write down, remember, AWS. We're now offering our personalized forecasts. AmericasWeatherSC.com. Use the promo code Starter23. Again, if you want your own meteorologist, we got plenty of them here. So feel free to sign up, try it out, see if you like it. And again, like I said, if you live in Minnesota or Wisconsin, I'm going to be one of your forecasters. So fun times. Alrighty, everyone. With that in mind, I hope you all have a great rest of your Wednesday evening. Boy, I almost forgot what day it was. Wednesday evening. We'll see y'all back here tomorrow evening for the next weather chat. In the meantime, keep enjoying that weather. Hope you all have a good rest of your evening. Take care.